But let's look at this in the center of mass frame of reference. In the center of mass frame of reference, here's object 1, here's object 2, and we know that the total momentum is 0. Shrink this for a moment. Okay. That's the definition of the center of mass frame of reference. M1 V1 plus M2 V2 equals 0. Well, that means we really don't have much freedom here. This tells us that V2 is negative M1 over M2 V1. So I really only have 1 degree of freedom here. Whatever V1 is, V2 is totally determined. But of course, I also have to conserve energy. So that tells me that my 1/2 M1 V1 squared plus 1/2 M2 V2 squared equals 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. But this equation up here applies both before and after. So I can write all of these in terms of V1. So if I know the initial velocity coming in, there's only 1 degree of freedom left, and that V1 here has to match up with that one there. This is a vector equation, and it works always. So what that tells me is that 1/2 M1 V1 squared plus 1/2 M2 times M1 squared over M2 squared V1 squared equals 1/2 M1 V1 final squared plus 1/2 M2 M1 squared over M2 squared V1 final squared. When the dust clears here, 1/2s cancel. Let's see, one of these cancels, one of those cancels. Factor everything out, and I get M1 plus M1 squared over M2 times V1 squared equals M1 plus M1 squared over M2 V1 final squared. This factor in front cancels out. And what I'm left with is that V1 squared equals V1 final squared. In other words, even in the more general case that it's not one-dimensional, as long as it's just two things colliding, in the center of mass frame of reference, the absolute value of V1 has to equal the absolute value of V1 final. But then also in the center of mass frame of reference, from this equation, that tells us the absolute value of V2 has to equal the absolute value of v2 final. All they can do is switch direction. That really makes a lot of sense. If we're in the center of mass frame of reference, if they both switch direction, momentum stays zero. And it obviously conserves energy because they both have the same magnitude they had before. But because of that, the relative velocity does not depend on our frame of reference. So in other words, v1 minus v2 is not dependent on the frame of reference. So the absolute value of v1 minus v2 in the center of mass frame of reference, it equals the absolute value of v1 final minus v2 final. So in all frames of reference, the absolute value of the incoming equals the absolute value of the outgoing relative velocity. Now, when we're in more than one dimension, those can change direction. They could come in this way and go out that way. But their magnitudes, the relative speed at which they approach or recede from each other, cannot change.